So for part A, they're first off telling us that the integral from -6 to 5 of this function is 7. We want to find the integral from -6 to -2. So we should be able to set that up as the integral from -6 to 5 of f of x dx should equal the integral from -6 to -2 of f of x dx plus the integral from -2 to 5 of f of x dx. You all agree with that? That's just sort of the basic idea behind integrals and adding and subtracting them, right? -6 to -2 plus -2 to 5 ought to be -6 to 5. And so we know that -6 to 5 is 7. And so we should be able to say that 7 minus the integral from -2 to 5 of f of x is equal to what we're looking for. And so then we just need to figure out what is the value of the integral from -2 to 5 of f of x dx. So we just need to figure out the area underneath the curve from -2 to 5. So first off, we see that this piece and this piece, not that piece, this piece, they should cancel each other out, right? This one's positive, this one is negative. Do you all agree with that? Same value, but one's positive, the other's negative. Okay. Same thing will happen with this little piece and this little piece. So that we can sort of ignore as well. So then all we need to do is figure out what's left in red here. And in order to do that red, I'll break this in two different pieces, the red piece and the green piece. And so the red piece we should be able to figure out by just finding the area of that trapezoid. So base 1 is 1, base 2 is 3, 1 plus 3 divided by 2 times the height, which is 1. So that one should have an area of 2. And then in green, it should be the value of whatever the entire rectangle here is minus whatever the quarter of that circle is. So the rectangle, rectangle or square is 3 by 3. So it ought to be the full 9 minus whatever the area of a circle, or of a quarter circle, 1/4 pi times the radius of 3 squared is. So that'd be 9 minus 9 pi over 4. And if we add the 2 to that, we've got 11 minus 9 pi over 4. And so we will say 7 minus 11 minus 9 pi over 4, which ought to be -4 plus 9 pi over 4, or 9 pi over 4 minus 4. Everybody okay there with part A? Okay. Let me give you the breakdown on that. That was worth 3 points. So 1 point if you sort of set this up or showed this idea of combining the integrals. 1 point if you successfully got a value for the integral from -2 to 5, and 1 point for the final answer for that -4 plus 9 pi over 4. All right. Everybody good there? All right, part B asks us to find the integral from 3 to 5 of 2f prime of x plus 4. This can be separated into two different integrals, right? One that is 2 times the integral from 3 to 5 of f prime of x plus the integral from 3 to 5 of 4 then the integral of f prime ought to be just f, and we'll evaluate that at 5, and f, and evaluate that at 3, and then plus just, this one just becomes 4x, evaluated from 5 to 3. And then we'll just figure out what all those values are. So going back here, f of 5 appears to be 0. And then f of 3 is 3 minus root 5. That's given to us. Where's the 3 minus root 5, right? And then plus, and then we got 20 minus 12. So we end up with -6 plus 2 root 5 plus 8, or 2 plus 2 root 5. Everybody good with that? Cool. And that was worth 2 points, 1 for going from this to this, and 1 for the final answer. All right, part C says the function g is given by the integral from -2 to x of f of t. We want to find the max of g on the interval -2 to 5. Absolute max, closed interval, which means remember that you're going to have to check the endpoints, as well as all critical values. So first off, we need to figure out what g prime is, and g prime ought to just be f of x using the fundamental theorem of calculus. So let's see this, a new page here for part C. We know that g prime of x equals f of x. We're looking for critical values of that on the interval from 2 to 5. So we want to know, when does f of x equal 0 on the interval from 2 to 5? So we look at the graph. -2 to 5. I should probably use the right values. So from -2 to 5, it equals 0 at -1, and it equals 0 at 1/2. So x equals 0, x equals 1/2. And we also need to take a look at when it's undefined, when our derivative is undefined. And so if we look at when our derivative of f is undefined, or sorry, not our derivative of f, but just when f is undefined, there are no places where f is undefined. So we've just got the 4 values, right? 0, 1/2, -2, and 5. And we'll just make a chart here to figure out the values of g of x. So starting at -2, then 0, then 1/2, then 5. So g of -2 ought to be pretty easy. That should just be 0, right? Because we know that g of x is the integral from -2 to x. G equals the integral from -2 to x of f t dt. So now we're looking for the integral from -2 to 0. So if we're looking for the integral from -2 to 0, that looks like that why did I put 0 on here? That's not actually a value. Our value is -1 that we said, wasn't it? Did I say 0 here? -1. Yeah, -1 is where I crossed through. Okay, so we're looking for the integral from -2 to -1 of f of t dt. So looking at that, the integral from -2 to -1, well, we're adding in 1/2 base times height, so we're adding in 1/2 of area to that. So that ought to be 1/2. And then if we go all the way to 1/2, the integral from -2 to +1/2, well, from -2 to 0, we end up with that canceling out, right? We already said that. But then from 0 to 1/2, we end up with -1/2 times 1 divided by 2, so -1/4. And then at 5, if we go all the way from -2 to 5, we already found the value of that integral, right, from -2 to 5, which was 11 minus 9 pi over 4, this thing right here. And we are looking for the absolute max or the absolute min, I forgot now. Absolute max on this interval. And so we just pick whichever one of these things is the largest. And it's clearly not 0. It's clearly not -1/4. This 9 pi over 4, let's see, what does that come out to be? That's what, about, a little more than 27, 28 over 4, which looks like that's clearly going to be larger than 1/2. So this is, our absolute max is 11 minus 9 pi over 4, and it occurs at x equals 5. Good there or no? Now we're 3 points, 1 for this, 1 for identifying at least x equals -1 as a value, and 1 for showing that it was at 5. Everybody good there or no? All right. And then D is asking us to find this limit. So x approaches 1. What was it? 10 to the x minus, minus 3f prime of x all over f of x minus arctangent x. All right, so as we approach 1, we end up with 10 to the first, so 10 minus 3f prime of 1 over f of 1 minus the inverse tangent of 1, which is pi over 4. So then we need to figure out what is f prime of 1 and what is f of 1. F of 1 is 1. So we've got 10 minus, we can get that in there in a second, 3 times f prime of 1. We got 1 minus pi over 4 in the denominator. If we look at f prime of 1, that's the slope of f at 1. Well, the slope of this is a rise of 1, 2, 3, 4, and a run of 2. It's got a slope of 2. So f prime is 2. So we end up with 4 over 1 minus pi over 4. And that was worth 1 point. Good or no? Any questions on that one? All right. Cool. Let's do another one. All right. I will give you another 15 minutes here to work through this one, and then we'll talk about it. Ready, go. So for part A, we are asked to find the value of f of -5. We're given that f of 1 equals 3. And we know that this graph of g is the derivative of f. So if we're looking to find the value of f of -5, that should be equal to the value that we have at f of 1, our initial condition, plus the integral from 1 to -5 of g. Right, so the initial point that we're at, 1, plus the integral from 1 to -5 of g, because the integral, because g is the derivative of f, the integral of g should give us value of f, right? And so does that make sense, right? This is f of -5 minus f of 1. So we just bring the f of 1 over here, right? If I write this, I should have written out maybe the first step. Integral from 1 to -5 of g of x is equal to f of -5 minus f of 1, right? Everybody good there with that setup? Okay, and so then it should become f of 1 minus the integral from -5 to 1 of g of x, because that's going to make that integral a lot easier to evaluate. F of 1 is 3, so it'll be 3 minus whatever the integral from -5 to 1 is. Well, looks like from -5 to -2, it should just be, what is that, height of 3 and 1, 2, 3 units there, so that should be 9. And it's underneath the x-axis, so it should be -9. And then we've also got this little piece here, 1/2 base times height, so 1/2 of 1 times 3, so 3/2, also underneath the x-axis, so -3/2. From -1 to 0, it's flat across the x-axis, so that's 0, and then from 0 to 1, it should be a positive value of 1/2 base times height, which should just be 1. And then we'll just evaluate all of that out. 3 plus 9 is 12, plus 3/2 ought to be 27/2, minus 1 ought to be 25/2. Everybody good there with part A? Okay. Part B. Oh, sorry, I should tell you guys, let's see what were the points on that. 1 point for getting the right value of this integral, 1 point for the final answer. Okay, so for part B, we want to evaluate the integral from 1 to 6 of g of x. Well, from 1 to 3, we've got a nice little square piece here. So we'll do the integral from 1 to 3 of g of x plus the integral from 3 to 6 of g of x, which is just the area underneath this curve that they've given us the function for. So from 1 to 3, that's just a square 2 by 2, so that should just be 4. And then plus the integral from 3 to 6 is the integral of 2 times x minus 4 to the second, which ought to just be 2/3 of x minus 4 to the third. Evaluated from 3 to 6. And so then you'll just need to figure out what all that is. So that would be 8 minus -1. So we got 2/3 of 9 in there, which ought to be 6. So we should end up with 4 plus 6, or 10. Everybody good with that? 1 point for splitting it up. Whether you wrote it as 2 integrals, not a big deal. You could have just said 4 plus the integral from 3 to 6 would have worked. 1 point for the right antiderivative, 1 point for the right answer. Good or no? All right. Part C, we want to know between -5 and 6, if there are any open intervals on which f is both increasing and in which f is concave up. So first off, to figure out if f is increasing, we need to look at the derivative of f. So we want f prime to be greater than 0, and we want to be concave up, f double prime to be greater than 0. Well, g is the derivative of f, so first off, we're looking for anywhere where if f prime is positive, then that means g is positive. And if f double prime is positive, that means that g prime is also positive. So we're looking at when is g positive? Well, g is positive from 0 to 4, and then from 4 to 6. So we could, 0 to 4, 4 to 6 is when g is greater than 0. And then when is the derivative of g greater than 0? So when is the slope greater than 0? That'd be from 0 to 1. And again, we have positive slopes from 4 to 6. So g prime greater than 0, 0 to 1, 4 to 6, both of those fall into the original 0 to 4, 4 to 6 interval for when g was positive, so the overlap is 0 to 1 and 4 to 6. Good or no? All right, and last part, part D, find the x-coordinate of each point of inflection for the graph of f. So if we're looking for points of inflection of f, that means that we are looking at f double prime, and as we said, f double prime is equal to g prime, so we want to know when does g prime equal 0 and when is g prime undefined. So those are places where we might have a point of inflection. So if we look back here, g prime, so the derivative of g, the slope is 0. Let's see, well, it's the slope is 0 all along there and all along there. But we could also, let's see. Okay. Can also just look for when the value of g goes from decreasing to increasing. And that only occurs at this one point here at 4. Right, so our slopes here go from negative to positive. All the other places where our derivative of g might be undefined, like here or here, our slopes go from positive to 0 or 0 to negative, or here, right, slopes go from 0 to positive or negative to 0. But here is the only place where the slopes go from negative to positive, or vice versa. So we'd say this is only at x equals 4, and you'd say something like this is a location of a critical value, and the value of g prime goes from positive to negative. Well, actually goes from negative to positive here. Good on that or no? Any questions on that? Everybody good? No?